Uh, the second important topic of photochemistry is the study of singlet and triplet states and their lifetimes. In this lecture, we will deal with these singlet and triplet states. What are they, and their relative stability. In most organic molecules, all electrons in the ground state, they are paired with each electron of a pair having opposite sign, as demanded by Pauli principle. You know that in ground state of the molecules, our electrons are paired. Overall spin comes out to be 0. When one of a pair of electrons is promoted to an orbital of higher energy, the two electrons no longer share an orbital. The excited electron may have same spin as its former partner, or it can have opposite spin. So when an electronic excitation occurs, this promoted electron, it goes from one orbital, it goes from orbital of lower energy to an orbital of higher energy. And this promoted electron, this excited electron, after excitation, it can have same spin or it can have an opposite spin to that of its former partner. But in UV visible spectroscopy, transitions between different spin states is not allowed. So usually singlet to singlet transition is allowed, triplet to triplet transition is allowed, singlet to triplet transition is not allowed. So initial excitation occurs with electron having the opposite spin, so that the overall spin of the molecule still comes out to be 0, even though the molecule is in the excited state. So here, we'll discuss about these singlet states and singlet ground state and singlet excited state. You have a molecule here. There are 4 orbitals. Pi 1 and pi 2 are in the ground state. They are occupied, right? So this is known as the singlet S0 state. S singlet stands for, all electrons are paired for this molecule, and if you count the multiplicity of this state, multiplicity of a state is given by m is equal to 2s plus 1, where this s is the total spin of all the electrons. And in this case, this total spin comes out to be 0. So 2 into 0 plus 1, it comes out to be 1. So multiplicity comes out to be 1. So for any state for which multiplicity is equal to 1, we call such a state as singlet state. So when all the electrons are paired, then S is equal to 0. And spin multiplicity comes out to be 1, and the state is known as singlet state. It's known as the singlet state. Let's talk about this state, excited state. This state, if you see, the molecule is now in an excited state, but the two electrons, this electron has been, it is excited. This electron is now in excited state. Okay, but it has opposite spin to that of its former partner. And if you see, the overall spin of this state still comes out to be 0. So when it has overall spin is 0, multiplicity will be equal to 2 into 0 plus 1. So it again comes out to be 1. So this is also a singlet state, but it's known as the singlet S1 or first excited state. Singlet S1 state it is known as. So the difference between S0 and S1 states is that of energy only. I hope it's clear. S1 has higher energy than S0. So if spin multiplicity is 1, then it is known as a singlet state. Take the example of this methyl free radical. It has one unpaired electron here. It has one unpaired electron. So total spin of this molecule, of this radical, this total spin comes out to be 1 by 2. So multiplicity will be equal to m equal to 2s plus 1. 2 into 1 over 2 plus 1 is equal to 2. So multiplicity comes out to be 2. So for any state for which multiplicity is 2, we call this state as a doublet state. So it's called as the doublet state. What about this carbonyl after spin inversion? So if we know the spin state of excited state of carbonyl after spin inversion, what happens to this? In this molecule, it's an excited state molecule, but this spin inversion has occurred here, means after singlet state spin inversion has occurred. Now these two electrons have same spin, they have parallel spins. So for this state, such kind of state, total spin will come out to be 1/2 plus 1/2, it comes out to be 1. Okay, so multiplicity will be equal to 2 into S total spin is 1 plus 1 equal to 3. So multiplicity is equal to 3. For any state for which multiplicity is equal to 3, this state is known as a triplet state. We call this state as a triplet state. So triplet state is possible when it is possible. It is possible when the electrons have parallel spins. They do not have opposite spins. They have parallel spins. So that state is known as the triplet state. So thus molecular species are states in which all electrons are paired are called singlet states. They are represented by Sn, where this n can be equal to 0, 1, 2, 3. So S0 means ground state singlet, S1 means first excited state singlet, S2 means second excited state singlet, S3 means third excited state singlet. And absorption of light always occurs without spin inversion. So this is what I said in earlier slide, that initial absorption of light occurs without this spin inversion. Means a molecule initially goes from S0 to S1. It doesn't go from S0 to T1. So spin inversion initially doesn't occur, and the initial excited state produced is a singlet excited state, which is known as S1 state. In this case, two electrons no longer share an orbital, and the promoted electron has, and this this promoted electron has opposite spin as it is to its former partner. They have opposite spins. Singlet excited state may, this singlet excited state that is formed as a result of initial electron excitation, it can undergo spin inversion. And after this spin inversion occurs, the new excited state has two electrons with the same spin, right? So if you count the total spin, it comes out to be 2, it comes out to be 1. So multiplicity will be equal to 2s plus 1, 2 into 1 plus 1 comes out to be 3. So such a state is known as a triplet state. We call this state as a triplet state, right? So these triplet states, they are shown by Tn, where n can be equal to 0, 1, 2, 3. T0 is the lowest energy state. T1 is the higher energy higher energy state than T1, or we can call it first triplet state. It can be called as first triplet state. I will write here. It can be called as first triplet state. S2, the second triplet state, which is higher than the T1 state. So the term singlet and triplet, they have actually spectroscopic origins. The origin of these terms is spectroscopic. The term singlet and triplet originate from the fact that the singlet state does not split in a magnetic field. This state doesn't split, while as the triplet state, it has an net magnetic moment is there, and it has 3 possible energy states in a magnetic field which are distinguishable. So this triplet state splits into 3 states in presence of a magnetic field. That's why it's known as the triplet state, and these 3 states are represented by +1, 0 and -1. So with this we have covered this singlet states and triplet states. In the next lecture we'll be dealing with the fate of the molecule, that is we have to study the Jablonski diagram. This is all for this for today's lecture. We'll meet next time inshallah. Till then, take care. Goodbye.